Okie dokes, okie dokes, okie dokes. I think let's get going. Yeah, I'm quite surprised with the numbers. I get the feeling that we are many more. But hopefully they join us sooner rather than later, because I think this is one of those you can very easily fall behind. Right? Very easily fall behind. And it's one of those that we're building on certain concepts as we go along. But yeah, how are you guys doing first and foremost? We are now second years. Huh? You said?
I was saying good results.
Man, I'm just. But it's good to see you again. I've talked to you before. Haven't?
No.
Yeah, most of you guys are not familiar. Oh, last year. You didn't do high stick with us. Okay. Last year was your first year here.
Okay. I see.
I didn't register you either.
No.
I'm getting old, guys. I'm seeing things. Yeah, no. Anyway, welcome. So as you guys know, here we're doing statistics. All right, guys. You know, the thing about statistics is you must just understand what statistics is all about. I think it's the mindset that you need to understand before you can go anywhere. And you know, this is why, like you'll see with all of the modules that I've lectured, I see I have no familiar face here. I typically lecture numeracy related modules. I don't usually lecture theory. I only started for the first time in my 6 years thereabout with Varsity College or with IIE. I only started theory modules this semester. So with numeracy modules, it really is understanding why are we doing what we're doing, what is going on, before you even touch the numbers. And then when you start to play around with the numbers, then it begins to make sense as to what we're doing and where we are going. Does that make sense? Okay. But before we go any further, I think it's important that I obviously introduce myself. So if you've checked maybe on VC Learn, all right. Okay, I think my device is also coming back from holiday. Okay, so my name is A. Okay, let's see here. I think maybe I'm not clicked on the right thing. Just a second. Hey, there we go. All right, so this is my name. Why? Why is it being so slow? For some reason, it appears to be freezing. Let's see if it will work if I just use. Okay, that's fine. Let's see if I have a marker in here somewhere. Okay, so yeah, this is my name, Aubry. Okay, and my surname is Senzani. Okay, right. Now, some people call me Aubrey, some just call me Sir, Mr. A. I'm comfortable with all of it. Most people just call me Sir, so no problems there. Okay. Now, with that said, I have a teaching philosophy. Okay, and I think this will work in good stead for you guys when it comes to numbers. right? I see. Are we in business? I don't know why this thing is freezing. I think I need to close it and reopen it. Okay. But that's fine. We won't let this delay us because we've already waited for our colleagues. So I'll just use the board. I'll just use the board, but let me close this in the meantime. Maybe I have too many things opened. Yeah, let's just close that for now. But my philosophy is UMA, okay? And that stands for, what do you think the U stands for? Yes, it is understand. First thing we need to do is understand. What are we doing and why? Okay? Then we move on to M, which is what? What do you think the M stands for? Managing. Nope. It's in relation to academics, studying. So after you understand, what do you guys now need to go and do? You need to go and master. Hey, I'm lecturing geniuses here. First time, understand. First time, master. Let's see if we get it on the A. What does the A stand for? Hey, I'm shocked. I'm shocked. This is the first time I've ever had that. It stands for master and apply. Understand, master, and then apply. When you are with me here in class, the objective is to understand, right? We will do a little bit of mastering, very little, because we'll do 1 or 2 exercises together, all right? But the real work begins with you and your textbook and practice questions, okay? Now, in your case, right, you guys don't necessarily need to use the textbook too heavily, right? What I recommend is that you definitely need to get the workbook, okay? You definitely need to get the workbook, okay? But before we go there and start talking about the workbook, which I'm going to pull out mine, okay? I want us to look at how we obtain our final mark in this module. So I want to take you to the module outline. Module outline. Okay. This is all about strategy. Okay. I think I'm going to need to kill 1 or 2 things here because my PC appears to be acting slow. Too slow for my liking. Okay, the other things, I think we need them, but let me close this. We'll look at timetables later. Okay, right now, that feels more like it. Okay, so just want to show you one thing. We have 9 learning units here, by the way. Okay, and this is what I want us to focus on. So guys, like I said, tertiary studies is all about strategy, all right? And I'm not going to speak too much about that because you guys are now second year, so obviously you have been doing something right, okay? And you have exposure to this place, you're no longer first year. But the whole point is that this is the first thing you should be checking whenever you start a module, regardless of what module it is, okay? Assessment 1, test. A test, sit down, close book, calculator formula sheet, all right? It's learning units 1 and 2, which I believe we'll finish today, okay? At least the theory side, learning units 1 and 2, the theory side. Don't worry, we are going to practice tomorrow as well, and look at questions and stuff, all right? So not completely finished, but that's what we're going to be looking at from a theoretical side. So that's 25%. It's an hour long, okay? And this is what I always tell my students, guys. That 1 hour, remember, you are also, when you practice, you're not only practicing so that you know how to answer questions, you're also practicing to ensure you're able to answer all questions within an hour. Does that make sense? So you're also practicing on your speed, all right? Then second assessment, 30%, 1 hour, 60 marks, closed book again, units 3 to 5, okay? And then finally your exam is 35%, 2 hours, closed book, calculator, formula sheet. Now, you need to learn how to use your calculator. This is why we also practice. It's not just about, formula, understand it, plug and play. You literally need to learn how to use your calculator. Otherwise, it will throw out the number and that doesn't look right and you'll be confused as to what to do, okay? So take cognizance of that. Then finally, what also makes up your semester mark is ICE. So I will put all ICE on VCLAN. There will never be a time where I'll ask you, let's do ICE and you pull out a piece of paper and work. No, because I'm lazy like that. So that thing will mark for us, and obviously it also allows you to do the ICE in your own time. Does that make sense? Okay. So now we know, guys, it only gets harder as you go along. Does that make sense? So we want to kill our ICE. Make sure you get your 10%. You'll have probably more than 4 ICE that I'll give you. Make sure you do as many as possible, because if the system, in other words, if VCLAN for some reason says you did not complete, there's nothing I can do about that because I'm not an IT guy. Does that make sense? So, but if you've done like 6 ICE, you know, then you know for sure you have your 4, which means for sure you have your 10%. Does that make sense? Okay, right. So when you look at ICE, if I'm lecturing it, you should be looking at it as this is free 10%. All right. I don't know how other lecturers kind of deal with their ICE, but I think it's in a similar fashion. Okay. All right. So we've dealt with that. Now, let me close this. Let's make sure we don't have windows open that we don't need. One last thing I want to touch on. Nope, that's not what I'm looking for. Guys, in the exam, you will get a formula sheet. I'm sure you saw there, it says calculator plus formula sheet. So this formula sheet is at the back of your workbooks. It's on page 177. I would advise that to every lecture you bring your formula sheet, because you need to make this thing your own. Does that make sense? So here they've even been so kind to say 1, index numbers, okay? Index numbers is learning unit 2. Learning unit 1, we are just introducing statistics, okay? Right, we're just introducing it. Then learning unit 2, measures of central tendency, okay? That, I think descriptive statistics is learning unit 3, okay? So there you go. But obviously you can see you will need to understand where to and how to use the formulas, okay? All right. But you're fortunate. Some students, when they were doing statistics, they did not have a formula sheet. They needed to remember these things off the top of their heads, okay? But that's fine. So we have dealt with the introduction. I don't know if there's anything you guys would like to share from your side. Any thoughts, concerns, matters you wish to voice? Nothing. Everybody's happy. Oh, and by the way, guys, I like engagement. I do not come all this way to just look at other people. I'd love for you to engage with me, share your thoughts, whatever the case may be. Okay. I'd rather not finish than finish and people don't understand. So at any point, feel free to ask me, sir, please explain that, or I don't understand 1, 2, 3. If I don't know, I will tell you. And then I'll go and look for the answer and get back to you. Right? And then get back to you. So, as I said, learning unit 1 is Introduction to Statistics, all right, which is chapter 1 in your textbooks, Okay, right, and here you can see the module outcomes, explain the meaning of data and statistics, describe the role of uncertainty in decision making, distinguish between various various terms, concepts, utilize statistical analysis. Okay, so really we're just getting to learn the basics of what is statistics, the terms, so that as we dissect it further, we know what it is that we are actually doing. Okay. All right. So, anybody want to tell me what is statistics? And if you don't have an answer, go on Google or ChatGPT, because I'm not answering that one for you. I want you guys to tell me what is statistics. And I always welcome guessing in my class, because then you can guess here and you won't guess in the exam, isn't it? Because if you guess in the exam, then it's a disaster for all of us. I see you next year. Obviously, things don't go well for you. Yes, sir.
Some basic stats are like now, like taking numbers like raw data and processing it, making sense of raw data.
100%, my friend. But before I go on, because I want others to also share what they think statistics is. Yes.
So I think everyone
Mm-hmm.
it's the same thing with taking information from different aspects, but you are it's like raw information.
Yes.
You're trying to make sense
Mhm.
of it by comparing the data of the information as well.
Okay, okay. Anything here? You have something here? I'm going row by row. What did I not do? Okay, we'll come back. Yeah? Anything from your side?
Same collecting and analyzing big
Big quantities of what? Okay. But you're on it, you're definitely on it. Any close from you? Nothing. Okay, no problem. Cool. All right, so it's exactly what you guys have said. All that we're doing in statistics is we are taking data, raw data, all right? Data is like raw information, right? Then we're processing that raw data through statistical techniques so that we can then get information, things like trends, all right, insights, all right, so that we can make decisions. The value of data lies in the term management decision support systems. Decision making lies at the center of every manager's job. Okay, so basically we're doing this analytics so that the business managers can make decisions. Would it be a good idea to invest in this company or not? All right, based off of the insights and the information that we are obviously retrieving as a result of our statistical analysis. Does that make sense? All right. Don't need to dwell on this. Data consists of individual values, each of which conveys little useful and usable information to management. All right. Unprocessed data is more readily available. Okay. It's easy for us to have unprocessed data. Examples of data may include the purchase value of a single transaction at a store. Okay. The time it takes a worker to assemble a single part. Okay? Okay. What is the value of that information? Okay. We need the time of each of our employees, right? Then we can average it out. Can you see the averaging is a statistical technique? Did you know that? Right? After averaging, then we're informed how quickly does it, or should I say, how long does it take our employees to complete one unit of a finished product. Then we can start to make decisions to say, how much can we promise to a customer by when? Because we know how long it takes. And we know we only have 8 hours in the day to obviously produce finished goods. Does that make sense? So can you see the decision making taking place? Me knowing how long it took her to complete a unit, that's just raw information. But now once we collect more data, and we use a statistical technique, then we can now start to make decisions. All right. Then information, right? While data is more readily available, information is not readily available to support decision making in the format, quality and quantity required by the decision maker. More often, information is generated from data. In fact, it is. To make informed business decisions, a manager needs high quality, evidence-based information on the relevant attributes of interest. Okay? The time it took to complete a unit, that was an attribute of interest. Okay? Now, what I like about this is they said evidence-based information. You know, oftentimes we say there are a lot of people who use cars and nothing. But if you're a petrol or looking to open a petrol station, you can't go and build a whole petrol station or invest in a whole petrol station just off of, there are a lot of people who use cars. Can you see that? We need evidence-based information. How many people in Gauteng are there first? And of that number of people, how many have cars? And of those who have cars, what is the average age? Can you see, if I get evidence-based information based on those criteria, when I start making an advertising campaign, I'm tailoring it to the age group of 28 to 35 or 28 to 65 or 70, because that's the age group that primarily has cars. Can you see how this thing is now beginning to make more and more sense? Okay, so very important that it is evidence-based. Statistics is defined as a set of mathematically based tools and techniques to transform raw and unprocessed data into a few summary measures that represent useful and usable information to support effective decision making. Okay, so now we're diving into the more academic definition of statistics. But I'm sure you guys can see in the definitions you gave, you can see that in what we've just read. Okay, these summary measures are used to describe profiles, in other words, patterns of data. All right, remember we were saying, okay, what are the patterns? Yes, people use cars in South Africa, but between this age and that age. All right, and then we can also begin to say, what is the disposable income of this age? Are there other products that we can sell to them? Yes, there are. So you know what? At our filling station, you know what we're going to do? We're going to sell chips and pies and things of that nature, because these people typically are busy. So they need something they can grab and eat. Okay? All right, let me go on. All right, we already spoke about evidence-based information generator. Okay, so here you can now see the lovely process. We've got data, right? It being processed, statistical analysis, and then you can see raw values, transformation process, okay? Then information is now produced, which is statistical summary measures, okay? Now management needs to make decisions, okay? Yes, we want to sell as much fuel as possible, but we can sell other things as well. What should we sell? We need to look at the age group of our customers. Our customers is between 28, let me say 25, right? And 68. The guys who are in their 70s, they typically don't travel, they're retired, okay? So we're not too focused on them. We're more focused on our more frequent customers, okay? What other things can we sell them outside of food? Okay, we have load shedding in the country. So what do we know fuel stations sell outside of just petrol? There's gas. There's gas, okay? So can you see the relationships, the patterns, the trends, which are informing our management decision making? All right. And the benefits, I believe, are pretty obvious, okay? So here you can just say, why should managers develop an appreciation for statistical methods and thinking? Okay, I'll just read through a few of them, right? Recognize situations where statistics can be applied to enhance a decision process. Okay, that we've already seen. Skip to the other one. Interpret intelligently intelligently, yes, management reports expressed in numerical terms. Okay? So here I think they were just basically trying to say, basically, the statistics allows us to intelligently interpret the numbers on management reports. Okay? Interpreting is key. There's no point of having balance sheets and accounts and all these lovely numeracy related reports, but we don't understand what's going on them. We need to interpret. Then critically assess the validity of statistical findings before using them in the decision-making process. All right. Initiate research studies with an understanding of the statistical methods involved. Okay. Communicate more easily and more effectively with statistical analysis. Okay. It allows us to summarize the data, right? Rather than have all this raw data, all these numbers of how long it takes each of us here to produce a unit, and then we are looking at all these numbers. Rather, when it's summarized, we know, okay, in a nutshell, what are you telling us via this raw data? All right. So the most vital of terms and concepts are, okay, so we'll look at this through an exercise, so we don't need to discuss that now. Okay, so here now they're talking about a random variable, okay? A random variable is any attribute of interest on which data are collected and analyzed. So earlier I told you that what? How long it takes each of us here to produce a unit. That's an attribute, okay? It's just a single attribute. Data are the actual values or outcomes recorded on the random variable, okay? And then here they give some examples. The travel distance of delivery vehicles, okay? Can you see? 34, 13, 21, those are random, okay? Those are random, okay? The daily occurrence rate, occupancy rate of hotels in Cape Town, okay? Again, random, because they can be anything for any of the hotels. Does that make sense? That's why we're saying it's random variable. It can be anything. You want to ask something? We're fine. Sure. Okay. All right. So let's go on. Okay. Now here they're talking about sampling. Okay. And guys, the slides are so comprehensive. I honestly believe you don't need to use your textbook. So I'd advise you just go through the slides and then you can begin going through question after question. Yes, sir.
So I just wanted to ask, you were saying the random variables, those units, the Ks and everything.
Yeah.
So those are, it's not data yet. Or are those units going to be?
No, they are data.
They are data.
They are data, because remember, data is just raw. So what is our point of interest? Maybe we should start here. Our point of interest is the travel distances of delivery vehicles. That's what we're interested in. How far does each of the vehicles in our parking lot here at Varsity College have to travel to get to campus? That's what we're interested in, right? So if I ask her, how long did it take her, right? I'm assuming everybody has a car for the purpose of this example, okay? It took her 34 Ks. How far did it take her? 13. So can you see those are different data points? So random variable is just basically saying data is random variables. Does that make sense? All right. Good question. Okay. A sampling unit is the object being measured, counted, or observed with respect to the random variable under study. Okay. So remember we spoke about hotels in Cape Town. That is the sampling unit. Okay. Hotels specifically where? In Cape Town. We have hotels across the country, but we are looking only in Cape Town. And hopefully that will be a representation of the total population of hotels in South Africa. Okay, right. A population is the collection of all possible data values that exist for the random variable under study. So if we said our study was pertaining to all hotels in Cape Town, again, that's the population. All hotels. All hotels would be the population, and then, the sampling unit, I'll be with you now, is then obviously Cape Town, because we're using that to kind of reflect the country. Okay, sorry, you wanted to say something? Again.
Just this one.
Uh-huh.
What's the rule of decision making?
The rule. The role. No, no, it's just speaking to managers should appreciate statistical methods because they allow managers to. So it's just these are the reasons why managers should appreciate statistics basically. Because obviously we're using statistical methods in order to do the statistics. Does it make sense? That's all that it is. There's no follow-up question. So obviously we're gonna just finish the slides. Within the slides they might be there, but also within questions, those that might very well be revealed. That might very well be revealed. Okay, so here I don't think we need to dwell any further. Okay, now a population parameter is a measure that describes a characteristic of the population. Okay, so for instance, a population average is a parameter. So just remember that it is a characteristic of the population. Okay, right. A sample is a subset of data values drawn from the population. So you'll see a lot of the things that are being said are actually kind of in a way repeating themselves. Does that make sense? Okay. So you see we have highlighted stuff. That's the key thing to take away. But ultimately, we already know that a sample is a subset of a population. Okay. It's a subset of a population. All right. Yeah. All right, so here they've given an example. A sample of 25 hotels in Cape Town is selected to study hotel occupancy levels, okay? So obviously the 25 is a subset of all the hotels in Cape Town. Are you seeing that? Okay, right. And there's just another example. We can't go through all of these, otherwise we'll be here forever. Okay, right. A sample statistic is a measure that describes a characteristic of a sample. Okay. For example, the average hotel occupancy level for the sample of 25 hotels surveyed. Okay. Is it making sense? Any questions? So far, so good. Straightforward stuff. Okay. Okay. And then there you've got examples of populations and associated samples. Okay. So here's your random variable, size of bank overdraft. Okay. Now what's the population? All current accounts with ABSA. Okay. Then sample unit, an ABSA client with a current account. Okay. Then sample 400 randomly selected clients with current accounts. Okay. So we can go on. You've got TV program preferences and so forth. So yeah, you can dissect this in your own time. Okay, then here, these are just the symbols that we use. Be very careful. Whilst we are measuring the same thing, it looks different for a sample statistic versus a population parameter. Okay, right. I didn't know that in my studies until I actually had to come lecture you guys. Okay. Then here we've got the difference between descriptive and inferential statistics. Okay. This is very important. Okay. So descriptive statistics condenses sample data into a few summary descriptive measures. Okay. These summary measures allow a user to identify profiles, patterns, relationships, and trends within the data. Okay, and then inferential, this is where we generalize. So we'll analyze the sample group, the 25 hotels in Cape Town, and then we will then say all the hotels in Cape Town. All right, or we'll assume. We won't say all, we'll actually just assume. Because when I say all, then it sounds like we've tested all. Does that make sense? So that's what we mean when we say inference, all right? Or that we're inferring, all right? Generalized sample findings. We generalize the sample findings to the broader population, okay? right? That's all that's going on over there. I don't want to dwell. Then here we're talking about statistical modeling, all right? And this is a lot of what we are kind of actually doing in my master's, okay? So statistical modeling builds models of relationships between random variables. So if we want to analyze the relationship, let's say between sales and marketing, right? So we ask ourselves, for every time that we advertise on radio, how much sales do we get? We want to see what is the nature of the relationship. Is there a relationship? Does advertising on the radio potentially yield us a sale? What do you think?
Not really, because some of them wouldn't want that.
Yes, your customer base.
Because you need a specific target for that.
Yes, 100%. And now the question is our target group listening to the radio?
Some teenagers don't listen to it. If your group is teenagers,
Yes,
don't listen.
they don't listen to it.
Social media is.
Their platform. But how will we know that? We have to test, right? Because we don't know until we test, all right? So, in testing, we'll then get data. When we get the data, then that's when we use our statistical models to assess whether there's a correlation, whether there's a relationship, okay? Now, in that assessing, we'll then establish, no, actually there's no teenagers who listen to the radio. So we haven't made any sales. Does that make sense? Then we'll try on television or we'll try on social media. And then we'll see our sales actually went up. And there can you see now we're establishing that there is a relationship between advertising and sales. The more we advertise, the more sales. Can you see that? But obviously, I think what you highlighted is very important. It's now dependent on the platform so as to get to our target market. All right. So that's all that I was really trying to illustrate, just to show you that statistical modeling is us trying to establish relationships so that we can then make decisions. Because if we know that advertising brings sales, right? We know that sales brings revenue. What are we going to do if we want to increase our revenue? We're going to increase advertising. Can you now see the relevance of statistics? Okay? So it's all just about understanding why we're doing what we're doing. And at the end of the day, we want to make informed decisions off of evidence information. Okay. So here it's just a nice graphical illustration of what we were talking about. Remember I told you the population is the entire group. Sample is a subset. And then obviously we use statistical modeling, whether it's on the sample or whether it's on the whole population, to then obviously explore whether there's a relationship or not. All right. Very important. I'm sure you guys might have had this in maybe high school, maybe spoken to some of these things. We usually do not test the whole population because it is large amounts of data. So it's very difficult to do. So we usually just try and identify a decent sample that will reflect the target audience or the information or the conclusion or solve the problem that we're actually seeking to answer. Does that make sense? Okay. But let's go on. Okay. Then here they're talking about differences between different types of data. Different types of data. Okay. And is it different types of data, nature of data? Select the most appropriate. Okay, so the emphasis here is that if we get poor data, we're going to get poor outputs. In other words, then we are going to get poor evidence information or information that is not very reliable, which will lead to poor decision making, right? Advertising via radio when radio is not the most effective form of advertising for what we're trying to achieve is a great example of that. Okay, and here at the bottom they're saying data quality is influenced by 4 factors: the type of data, the data source, all right, the method of data collection, how we collected this data, and then the appropriate data preparation. So you'll find that the raw data, remember we spoke on how far does each of us have to travel in order to get to campus. Before we can analyze this data, in other words, before we can average out the data, we need to obviously prepare the data. So we'll probably put it in an Excel document, put the name of the individual, put the distance, right? And then only we can average it, all right? Does that make sense? So we have to collect it and then obviously prepare the data in Excel and then do what needs to be done, all right? We've already looked at what type of data that would have been. It's numerical because obviously it's a number and not just quantitative. It's not verbal or written, all right? So here now they're just letting us know that your random variable, in other words, your data is either going to be numeric, which is quantitative, or qualitative, which they also refer to as categorical, which is, in other words, like words or letters, all right? Right, all right, so then here they're now just giving examples of qualitative data. So a customer's choice of mobile phone services provided may be Vodacom, MTN, all right, Cell C. So there, can you see, none of those are numbers, okay? I might be boring you to death here with that, but these are the fundamental principles that you guys need to make sure that you understand so that when we get into the crunching, we're more than comfortable. All right. So when they're talking about quantitative data, again, we said that those are numbers. And then it says here, these are real numbers that can be manipulated using arithmetic operations such as addition, subtraction, multiplication, and division. Okay, so these are things that you guys have seen before. We spoke about averaging earlier. Okay, when it comes to categorical, right, or non-numeracy data, we then need to employ transforming that data into numerical before we can actually begin to statistically analyze it. Okay. Then very important, when it comes to numeracy related data, we have discrete and continuous. Discrete is when you have actual full-on numbers, also known as integers. Okay, so integers 1, 2, 3, these are flat numbers, so to speak. All right, and whereas continuous is where you have 28.4, 29.01, that type of thing, where you got decimals. Does that make sense? So we call them continuous because you can have almost any number in a way between 27 and 31. When I say any number, I mean 21.000001, right? 30.02. We can have all sorts of numbers. Does that make sense? That's why we call it continuous, because we can never end the type of numbers we can get between 27 and 31 when they are continuous. Whereas if they are discrete, they are whole numbers, we can only have 28, 29, and 30 between 27 and 27 and 31. All right. And then here, and I think maybe we'll pause on this note. There are 4 types of measurement scales. Okay, you've got nominal, ordinal, interval, and ratio. Okay, and we'll talk more to those once we come back from the break. All right. Otherwise, are there any questions or thoughts? That's fine. That's fine. Nothing. Everybody is happy. Okay, so yeah, let's take our break, and then when we get back from the break, we'll finish off our slides. We have 3 sessions today, isn't it? Okay.